All right. Hi, everyone. My name is Simon, and I work as a researcher for Wild Animal Initiative. I finished my PhD in ethology at Stockholm University a couple of years ago, and since then, I've mainly been sort of thinking about and working on wildlife contraception or wildlife fertility control, um, and sort of potential for improving wild animal welfare using it. So this has been worked together with Luke Hecht and Victoria Elliott. Victoria's here at the moment. Um, so we also have a related upcoming paper, this sort of general topic in the journal Bioscience. So fortunately, or like hopefully, will be published in the next couple of days or so. Yes. Okay. So fertility control is usually discussed as an alternative to other potentially sort of less humane methods or harmful methods of culling or poisoning animals. Um, and so I've taken the example of rodenticides because it's a fairly stark example. But I think that there are like other potential benefits to wild animals that are worth exploring. And so they relate to things like reduced reproductive sort of energetic input. So somatic maintenance in would-be parents might be sort of increased because they're not putting their effort into producing offspring to the same extent. And there might be reduced sibling competition. If there are fewer siblings, they might get more of the resources. And there's also, which is the focus of this talk, the potential for improved welfare generally for animals in the population if there are just fewer animals overall. Yeah, so while I'm sort of optimistic about this, I don't want to sort of make it seem like it would always be a good idea to implement fertility control. There are a lot of ways that you could encounter side effects or cause negative welfare effects when implementing it. So it could be like infections from the wound if you're injected, or there's surgical sterilization comes with risks. But yeah, for the purpose of this talk, we'll mainly sort of assuming side effect-free version of wildlife fertility control. Okay, so just some quick basics on what we're trying to sort of model here. The like a standard model for population growth. You have the sort of the green dot down on the left-hand corner. On the left-hand side here, represents sort of the initial conditions, and you have the sort of maximum possible growth rates. And as you approach carrying capacity, either survival or fecundity, or both, will have to decrease such that the growth rates levels out. So net zero growth, basically. And this assumes no migration, basically. And then if you apply fertility control, then what you're doing is you're sort of introducing a reduction in fertility. And it's then expected that you might have like compensatory increases in survival, for instance. So that would otherwise, if reducing fertility, then you would just see a continuous drop in the population size goes extinct. Right. So Okay, so here I will sort of assume a relationship between age-specific survival and age-specific welfare. And there are arguments for and against assuming that relationship. I think there's some evidence that sort of like specifically age-specific survival can be useful proxy for welfare. And we might expect something like this relationship here, that as population size increases, you see a decrease in so this middle and linear density dependence of welfare, decline in average welfare. It might be the case that you see sort of a sharp early decline, as in the concave shape, or the convex density dependence, depending on exactly what factors are causing the decline in population size, or sorry, causing the decline in welfare. For instance, you might have a type of disease that will reach a sort of epidemic threshold once you are at a certain population size. Okay. So an exclusive focus on average welfare would sort of likely motivate us to keep wild animal populations small, then sort of balancing potential social needs, but keeping them small enough to minimize these negative effects of things like competition and disease. However, in this example here, reducing population density may increase average welfare, but it also reduces the number of individuals that are able to sort of benefit from the use of this, and from a lot of different ethical and practical considerations, that might not be the best solution to keep populations sort of as small as possible. Okay, so in this case, it matters if we're looking at total welfare, summing across individuals. Then it matters what the shape of this this density dependence of welfare is. So if it has this convex shape, we might expect a modest reduction in population size. Relative to partner. Okay, so this heat map summarizes what explain in quantitative terms. So as the density dependent index.
Hi, can people who are joining online please mute their microphones? Thank you.
It's because we have somebody online who doesn't mute and they don't read their messages, so we're
Right.
trying to signal here. Apologies.
Yeah. So, the density dependent declines in welfare become more severe. And the more sort of convex the shape of the density dependencies, so further up and further to the right, we see an increased potential for sort of improvement in welfare due to sort of reduction in population density. Okay. So I've just placed a few different species of animals in the rough quadrants of this heat map that I think that they belong in. This is certainly not anything I'm we're very confident with, but so some evidence of them belonging in these areas. And in particular for one species, and that's donkeys, there is some data that we were able to use to sort of try to answer questions around the exact placement of where they are on this map. And that's from a paper by Chalkinot from 1991, where they looked at donkeys in different populations in Australia. So they, as I said, they reported demographic rates for two different populations. One in its carrying capacity, and you can see that in the lower right. That's the sort of the dot and the box lower right. And one at roughly half of the carrying capacity, what probably is the carrying capacity. And so it had roughly 19% annual growth rate in the smaller population. And so yeah, it's possible to that, based on some other sort of data that are reported on in the paper, possible to make out a rough shape where exactly this dot is supposed to be. And so it seems like it basically fits a convex shape. So they mention in the paper smaller populations that seem to have similar growth rates, and it seems plausible, at least, that these populations of donkeys do follow sort of this shape in terms of negative effects. And this is still sort of assuming this relationship, like it says welfare here, but it's sort of assuming a relationship between each specific survival and each specific welfare. We're using the survival to calculate something, each specific survival to calculate something that is called welfare expectancy. Is it my colleague? No, 21. Yeah. Okay, so here we now model the potential for improvement using fertility control. And as you might be able to tell from the map, there's an area over here with sort of assuming more convex dependent shape, and reduction in fertility that's around 50%. If you go beyond somewhere, then the population is unsustainable, and so it's like too strong and it will event extinction. And so matrix population roughly place the donkeys over here, and yeah, so it's obviously not an exact placement, but somewhere over there. Okay, so I need to move on, I think. So basically, I think I can say with some confidence that yeah, it seems like the fertility control might be able to harmful main thing that trying to present at the moment. So it obviously depends on the specifics of the populations, and especially for populations where we have like strong density dependence and where the you have sort of more of the convex shape, expect stronger effects, potential beneficial effects. And so looking forward, what would be useful to sort of expand this research, and sort of expand on it in terms of other like empirical tests. But it would be very good to sort of try to test the usefulness of different indicators, sort of this assumption of relationship between survival and welfare, and enough data to be able to tell the shape of the density dependence. Because if you have just 2 dots, it's hard to tell a shape, so you need 3 dots. So we really have to sort of stretch the data that we had, make something useful out of it. And lastly, it would be very useful to see more studies on wildlife contraceptives. See where the sort of negative effects might be and how to. Yes. Okay. So, thank you.
Thank you very much, Simon. So, questions?
Thank you for a very interesting talk. Reminds me of my old philosophy days. I have a question, because now you assume that every animal is an island, so to speak. In many cases, if one herbivore is being controlled, then some other herbivores may go up, and that may have a huge effect on their welfare.
Yeah.
And if we're talking about carnivores versus herbivores, then you can take the feed stuff away from some animals, will affect their welfare. Sort of, have you any ideas of how to develop this into a way where you can actually see the net welfare on the animal kingdom and not just on your selected species? Because I think the risk here is that you simply do something for one species, but have an enormous amount of knock-on effects that you don't account for, and that way you're just left in the dark about the net welfare, which seems to be what you really care about.
Excellent question. I think that is definitely a problem that I've been trying to grapple with. It's very hard to actually, it becomes extremely complex very fast as you try to incorporate information from what happens, the sort of knock-on effects. And yeah, that is one thing that I didn't talk that much about here or at all, is that you might see if you have two different competing species, for instance, that compete for a certain resource, and your mechanism for potential improvements is reliant on sort of release of this resource, that now you have more for everyone. If you reduce one population or sort of one species, and the other one is sort of capitalizing on this resource now to a larger extent, then it's sort of negating some or almost all of the effect that you're wanting would have. So I think it's just, this is mainly to sort of point towards an interesting general area, and I think it would be good to have more research on this, but it's not, I'd say, it's hard to know, and it's I think there are ways to address those questions, but it's harder. Yeah.
Is that working? Yeah. Thanks for your talk. I just wanted to ask one question about one of the assumptions you seem to have in your graphs, which is that as population size increases, welfare inevitably goes down. So isn't it possible that actually there are optimal curves which go up from 0 because you know, animals form groups for various beneficial reasons.
Yeah.
So you wouldn't necessarily expect that, and that may change the whole way in which you
Yeah.
model it.
Yeah, definitely. So there are, when we're talking about like population growth rate, like now I don't want to like just switch welfare for growth rate. It's not gonna, like, population growth, it's not gonna be the same thing. But there are these Ali effects, for instance, where like you might see that if you go below a certain population size, it's unsustainable. So one reason for that could be, as you said, like a collapse of the sort of social structure, the living groups, and it's like not enough individuals to collaborate, stuff like that. So definitely, I'm not sure. I guess it depends on, like, because that's more towards the end, like quite small populations. So it depends on like the benefits. The easy way to provide benefits might be further to the close to carrying capacity, and so exactly what happens down there might not be as important for these questions, but certainly it's not going to be the case in sort of every situation. You have this neat, monotonous relationship. Thanks.
Can I just say, while we have a break, that I apologize for the online participants that you can hear. I'm not the host of the Zoom, so I can't mute them. We are trying to work on it. And can I please, if you can hear me online, please mute all your microphones. Thank you.
Okay, so we're ready to start. So I'd just like to introduce the next speaker, Julie Lane, who will be talking about ending rodenticide use. Could fertility control be the answer?
Thank you. Oh gosh, that's a bit high. So yes, thanks for that. Many thanks for the introduction, and thanks for the offer to talk today. So yeah, I head up the National Wildlife Management Centre in the UK, and we work on any sort of human wildlife conflicts. And I wanted to talk to you about rodenticide use in rats, because it's one of my big bugbears that we don't do more about this. And also one of the big areas that we're working on, which is fertility control. So I'm glad Luke set the thing in section so that it looks like fertility control is a good thing, hopefully. So I'm really struggling not to move. I'm a bit like Claire. I need to pace. Anyway, it's very timely, this talk, because the 4th of July was a very important date, not just because it's Independence Day and because we got a new government in the UK, but also because we have now banned the use of rodenticide, second generation rodenticides, to be used out in the open. So you cannot buy rodenticides from now on to use in the open, which is brilliant for secondary poisoning. This is a really good idea, but it doesn't do our poor rat any good. So it just basically stops it, affecting birds and things. It's still a good move in the right direction. But just going on from the sort of graph that Luke showed, this is a graph showing the fecal corticosterone as a measure of stress in rats with a high dose of rodenticide, the LD90, in red, and a low dose in blue. And you can basically see that after the black line, is where the poison is given. You can see the level of that fecal corticosterone in the high dose. These animals are suffering, and they suffer for days, not for minutes, not for hours, for days. It is dreadful. It's a horrendous way to kill an animal. I feel that there's a certain lack of, I don't know what the word is, iconography for these animals, is that, rats, we don't care what we do to them. Bushy-tailed rats, squirrels, we care more, but rats, we don't care. So, but it is a real big welfare issue. So what alternatives are there currently? Well, we can use spring traps. That is one alternative. And in the UK, we do have the spring trap approval order. So the traps have to be proved to be humane. However, it depends on your version of humane. So there's a number of what I would call traditional spring traps, like these BMIs on the side there. And we have these new ones that have just come out, good nature traps, which are repeated kill trap, but these kill the animals. From a humane trap point of view, traps have to kill 80% of the animals within 300 seconds. Okay, so 5 minutes is still quite a long time to be in pain, but also there's no upper limit for the other 20%. So actually they could take days to die and it would still pass. So spring traps are an alternative, but there are obviously issues with that. There's lots of other things you can do, which are quick ways to kill animals. You know, you can break the neck and do cranial concussion. And I do apologize, I'm talking about death just before lunch. And also, of course, you can shoot. But in order to do that, you have to actually catch the animal. And I think sometimes we forget about this when we're thinking about welfare, particularly management methods. So if you catch an animal, there is a massive impact on a wild animal to be caught in a trap. In fact, we quite often think this is the worst bit of the whole management procedure, is the trapping. And to demonstrate this, this is some work that we did looking at cage trap. So this is a wild rat caught in a cage trap, and we monitored its behavior and its physiology. And we left it for 13 hours, and you can see even at 13 hours here that it spends more than 2/3 of its time in escape behavior. So scrabbling at the trap, biting at the trap, trying to get out. These animals are stressed. This is not going to be good for them. And this is backed up by the fecal corticosterone. So when they're in the cage, the fecal corticosterone, as you would imagine, they're very stressed, it goes up. But even a day later, the corticosterone is still high. So even a day afterwards, they are still suffering. And when I say in the trap and the day later, we take the feces that's corresponding to when they're in those times, if that makes sense, just in case anybody tells me that I'm measuring it wrong. So you can tell that these animals are really stressed. So think about that when we're thinking about cage trapping. It's certainly not it's certainly not without humane issues, cage trapping an animal. So one of the things we definitely would advocate is prevention is better than cure. So we did some work with BPEX, a pig committee, where we went around pig farms, basically saying, please tidy up, please put lids on bins, food bins, remove nettles so the rats don't have harbourage. And you can have a really massive impact on rat populations by doing this. You could still argue that probably the welfare isn't good because we're taking away their food and their harbourage. But maybe that's a talk for another time. So there's lots of different ways we can do it. But what I want to talk to you about today is fertility control. Now, there's fertility controls being used quite readily for other species. So there's something called PZP, which acts, basically stops, makes the outside of the egg slippy so sperm can't get in. So that's how that works. And that's been used in things like feral horse populations. And diazepam stops cholesterol being converted into sexual hormones, and that's quite often used for birds. So this has been used for pigeons and parakeets and that kind of thing. But every type of fertility control has its limitations. And PZP and diazepam only work on PZP only works on females. Diazepam does work on males, but it's better for birds. There are quite a lot of issues if you use them in mammals, because basically you can overdose and then you start getting issues. So we've worked on both of these, but we've settled working on anti-GnRH. So these are compounds that basically stop gonadotrophin releasing hormone, which is the top hormone, controls all your sexual hormones. So it blocks that. So what it basically does is stop that being released, which basically means that's a lot of basically, apologies, but it stops testosterone and estrogen being produced. So it works equally as effectively on males and females. The other thing about this is that we can't overdose on it. It doesn't seem to make any difference. If you give too much, it just has the same effect. So we've decided to concentrate our efforts on these anti-GnRH ones. And we've had quite a lot of success in some animals. So these, as an injectable, we use something called Gonacon, which is USA made. And for a single injection into wild boar, they were infertile for 10 years. So that's one injection. We saw no welfare effects. We may have missed some. I don't doubt we may have missed some, but we saw no welfare effects. We didn't see any change. These are captive boar. We didn't see any changes to the dominance hierarchy. And the only thing that we did when we finally post-mortem these animals at the end of their lives is that there was a tiny granuloma where we'd injected them, which is what you'd expect. It's a vaccine. So it's a bit like having a TB vaccine. You're going to have a little lump where you put it in. That's where we know it's worked and caused an immune response. So that worked really well. And in America, they've also used it on the Californian ground squirrel. And again, one dose reduced fertility by about 90-odd%. So it works really well. Just to give you an example of us using this in the wild, and as I speak, my colleagues in Wales doing this, and apparently have better weather than we have. So I feel I should have been out in Wales chasing goats. So this is a study of feral goats. So we've been doing this now. I should have looked that up before I came. I think it's about 15 or 16 years. So in Wales, there's a population of goats that live up on the hills. And what happens if they get over a certain number, instead of staying up in the hills, they come down and eat people's flowers in the garden. So, so the Welsh local community want these animals managed, but they don't want to cull them because that, you know, it's their animals, it's their little mascots. So we've been actually injecting these animals with Gonacon. And we go every 4 years. So an injection lasts at least 4 years, inject the animal. And then what we do is we model the populations. And then in 4 years' time, we go back and know how many we need to inject so that we keep the population constantly under 100. And it's worked remarkably well, a lot better than I actually imagined it to work. And the only time I had an issue was during COVID and we couldn't go. And again, as soon as we didn't go, it was on the news, these goats in people's gardens. So it definitely does work, but we've got to capture the animals. So obviously for rats, we're not going to go around individually catching rats and injecting with a fertility drug. That would seem a little bit daft. So we need to think of getting an oral contraceptive. So we're currently doing a big project on grey squirrels. We're trying to develop an oral fertility drug for grey squirrels, basically because they're absolutely wrecking our trees and causing issues with our biodiversity. It's a huge issue. And people don't like killing grey squirrels. So we've got money to look at fertility control. We're doing it in 3 stages. So developing an oral contraceptive, then how we deliver that, and then modeling how that will happen, how that may or may not work. So obviously from our point of view, if we talk about rats, I just talked to you about the development of the oral contraceptive. So we're working with a company called Sporomex, which do this amazing thing. I was absolutely blown away by this when I first heard about it. They get pollen grains and they take out, so I'm going to have to use my hands because I just demonstrate, it's just so amazing. They get pollen grains and then they take out the DNA material from these pollen grains. And then they've got a natural capsule so they can fill it with anything that you want, as long as it fits into a pollen grain. And so we're using these to actually deliver an oral contraceptive. So it protects the vaccine from the acidity of the stomach. They're very, I don't know if you've seen pollen grains and fungal spores, they're very hard and sticky. And it also enhances the release through the gut. So that's what we've been doing. We've been taking a gonadotrophin releasing hormone antagonist, a vaccine against it, and putting it into these little pollen grains. Now, I said to you that we're developing, thank you. I said to you that we were developing an oral contraceptive for squirrels, but in order to do that, we're using rats as a model, because squirrels only breed twice a year. We would be, you know, decades down the line if we were waiting to try it every time. So we've been using it on rats. We're making it quite difficult for ourselves because these antagonists work best when you've got very low levels of estrogen, and rats obviously cycle every 4 days. So we are making it difficult for ourselves, but we have been using them, and we've tested multiple types. And we've actually got one that works really well if you squirt it into the mouth. So if you get a syringe, squirt it into the mouth, it works brilliantly. All the rats were infertile, all had very high titers. We then tried to feed it, and we got a less good result. We were still quite impressed, to be brutally honest. So we got 40% of the rats had an immune response indicative of being infertile, and 20% were fully infertile. So, and that was from voluntary bait uptake. So this is giving them the bait once a week for 5 or 6 weeks, which we're trying to monitor, because this is for squirrels. We're trying to monitor what a squirrel would likely to take. So this is 6 doses over 6 weeks, but just giving them it once a week. So what we want to do now is try and refine this. So we think we may be able to refine this in a number of ways, which I won't bore you with, but we can use a different type of adjuvant, which might increase the fertility. We can also increase the dose, because we're trying to do a very low dose, because obviously the lower the dose, the better. So, but it definitely works. We do get good getting it to work. So we just need to refine it to make it work in a bit more of the population. So just to quickly finish then, why should we use fertility control instead of any other kind of method? Well, basically, the way I feel of this is that it's evolution, not revolution. And what I mean by that is that people are used to using baits. They're used to putting rat poison out. So actually, if we say to a pest control, instead of putting rat poison out, actually put this fertility drug. It doesn't need any technical skills. It doesn't need any retraining. So I think it's got a bonus there. Obviously, there's massive welfare impacts, and it's also publicly acceptable. So 60% of the public, which still seems quite low, but this is for squirrels, 60% of the public said that they would find that acceptable. I suspect for rats, it would be a lot more. And it's also completely safe for birds, which will keep a lot of our ornithologists happy. It doesn't affect birds at all. So just to finish, I would just like to finish with a statement from Sandra Baker, which I'm assuming some of you will know, that rat management may represent the greatest source of anthropogenic impact on wild animal welfare. And I think that is completely true. And that's me. Thank you very much.
Very much. Do we have any questions? Got a couple here. Hi.
Yeah, so I'm Michael Beaulieu from Wild Animal Initiative. So you showed that you had very high efficiency in terms of reducing fertility in wild boar and goats. I was wondering if you also measured how the body condition or the survival of these animals varied after your treatment.
Yes, so the boar, we did full postmortems on the boar after the 10 years. So they'd basically had one injection, but they've been infertile for 10 years. And like I said, the only thing that we found was the granulomas at the injection site. We didn't see any difference between the control and the treated in any other way. So they weren't, we half expected the controls to actually, the treated to actually be better physically, but we didn't see that. And the controls had birthed. We didn't see an obvious difference. Things like organs all look the same, fat levels slightly different, but nothing that you would put a welfare issue on. So yeah, we saw no difference. Yes, in survival. I mean, these were captive wild boar. We have done work in the wild on wild boar. But unfortunately, we, which I was mentioning to Claire earlier, we had an issue because poachers kept killing our wild boar. So we didn't get a huge amount of data. They kill the wild boar and then sell our GPS collars back to us. So, we didn't see a difference, but it wasn't huge numbers because they kept killing the things. So.
Hi, Julie. Thanks for your talk. I'm Moira Harris from the UK. I have a question about your measurement of rodent stress using fecal corticosteroid metabolites. So I understand that fecal sampling is convenient and it's non-invasive, but is fecal corticosteroid not more of a long-term measure of stress, whereas you were looking for acute stress?
Yeah, we've used although fecal corticosterone is used for longer term, we have shown that it can pick up, it can actually pick up short-term stress quite easily. So we've even done circadian rhythms with fecal corticosterone in rabbits. So you can pick up short-term stress. You just have, so we verified this a long time ago, but we verified this with plasma, and you have to work out obviously when the corticosterone is equivalent to when it was plasma. So the cage trap, these were the cage trap samples we took 20 hours after them being in the cage trap, and again the day after 20 hours. But it does work. It's
Thank you. So are these got caught in a cage trap and injured for 20 hours?
Sorry, can you repeat that? Sorry.
These are rats that have got in the trap but have not been killed instantly. They've been injured and then lasted no.
So what this was, sorry, I didn't go into great detail because of time, but this is, we have these large rat arenas at my place, which are sort of the size of this room, a little, maybe slightly smaller, where we can let rats like live in a population. So we catch wild rats, put them in there, habituate them, and then we put the cage traps in, catch them, and then we monitor the fecal corticosterone the day after. So that's how it's sort of captive wild rats, but trying to be as wild as possible.
Thanks for the talk. Laura Kubashevich from the Donkey Sanctuary, UK. Hello. I was wondering if you've looked at or have plans to look at the potential for uptake by non-target mammalian species when you put this in the wild.
Yeah, so that's a big part of the squirrel project. The advantage of this is that for rats, we already have rat boxes, which you know, that you put rodenticide in, so it would only let rats in. So we've been doing quite a big piece of work monitoring, developing ways in which we have, you know, a variety of ways of stopping other animals get in. But from a squirrel point of view, this is proven quite a big part of the project. So we have a variety of methods like weighted doors, etc. But for rodenticide, we already have all those for rats. So it will affect mammals if they eat it. What we know is that it doesn't go, it gets degraded, which is why it's quite hard doing it orally, to be brutally honest, but it gets degraded in the gut. So it's not a risk to the environment. It's only a risk if the animal actually gets in the box and eats it.
Thank you.
We had loads of questions, but thank you again, Julie. So I'd like to introduce the next speaker, Daniela Haager, talking about assessing animal welfare risk in fibre-producing animals.
Hello, everyone, and thank you for having me. The topic of my presentation already was introduced, so just skip to the next slide. So I'm confused. Click here. Before I actually touch on the topic, I shortly want to introduce the organization I'm working for. I'm working for VIER PFOTEN. It's an animal welfare organization based in Austria, and we are working on animals under direct human influence. And we're trying to reveal suffering rescue animals in need, and also protects them. And For Paws was funded in 1988 in Vienna by Heli Tungler, that you can see here on the picture, and friends. And the organization stands for a world where humans treat animals with respect, empathy, and understanding. And For Paws has also a long history with textiles, having evolved from a specific focus on fur, becoming a leading force in animal welfare in textiles. And here you can see, as I already mentioned, Heli Dungler, our founder, actively working on the street and demonstrating against fur farming in Austria. But we didn't only do demonstrating in the past, but we are still continuing campaigning against fur farming. And we have our leading campaign, #FreeFur Europe, if you're interested in. And we're also campaigning against cruel practices such as live lamb cutting, also known as musing in sheep. But the main campaign that we are running and why I also here presenting this risk assessment is named Wear It Kind. And our umbrella campaign, Wear It Kind, also is a vehicle for improving animal welfare in the fashion industry across the globe. And how we are actually doing this, like trying to improve animal welfare in the fashion industry, will be the topic of the next slides. Just to give you a bit of a background, how many animals are affected when talking about the fashion industry. So annually, there are 5 billion animals affected, so to say. And the fashion industry or fashion companies have almost no idea, or I would say are unaware of the animal welfare issues within the industry. And I also brought this graph so you can see where are the main producers and global players of the fashion industry. So China is one of the major players, and 90% of all geese and 75% of all ducks are farmed in China. There is also 60% of the world's fur produced in China, and 60% of all cashmere comes from China. Australia is a big player in the wool industry. 80% of all merino wool that is produced actually originates from Australia. And in South Africa, we have 60% of all mohair goats farmed, and 85% of all alpacas are farmed and kept in Peru. And there's also Brazil on the slide, with 20% of all the cattle worldwide are farmed there. And Brazil, together with China and Australia, are the main players when it comes to leather production. And just to give an overview why this is important to keep in mind, only 1% of the down that is produced worldwide is certified, and also 2 to 3% of merino wool is certified. And when it comes to animal welfare, it means it's basically nothing certified. And this is why certification or animal welfare certification is only one way that brands can ensure level of animal welfare. And that's why for us as animal welfare organization, certification is something really important when it comes to animal welfare. Just to get you an idea how the certification works and why it really matters. So imagine you're a standard owner, like there's a big standard owner called Textile Exchange. They create some kind of a set of criteria that needs to be met by the producers. And in this criteria, the producers or the standard owner can include, for example, animal welfare, also labor laws or biodiversity rules, for example. And when these criteria are developed, then the next step is actually the certification process. And there producers, such as wool growers, they are joining the scheme voluntarily. And then there are certification bodies like Control Union who are auditing this producers so that there's actually ensured that these criteria are met. And one example of such a standard would be the Good Kashmir standard, for example. The Good Kashmir standard promotes a humane farming of the goats and also some kind of sustainable farming practice. However, although certification doesn't always guarantee excellent animal welfare, it may it means that it's at least something there instead of not being non-certified. And for PAWS, certification is a key tool in driving also improving animal welfare. But besides for us to improving animal welfare, it also helps that producers can get through more sustainable practice on farming, maybe more reward from the market. For producers, it could also mean that they could enter other markets, for example, the EU, and also brands that want to focus on more ethical sourcing of the fibers they're using. And also brands can verify the claims through a certification. And in the end, customers can rely via certification and help to make them choices that actually fit to their values. But why a risk assessment now? So the aim of for PAWS assessment was or is to provide brands with a comprehensive understanding of the use of each material of animal origin from an animal welfare perspective. And the assessment aims to identify the most appropriate certification with regards to animal welfare to be adopted. And in this way, brands are responding to consumers' beliefs that animal welfare is a very important issue for companies and fashion brands to address. And to better understand the animal welfare risk associated with farming of fiber-producing animals, we evaluated 17 of the most popular animal welfare textile standards across quite a range of materials. And our evaluation focused on the animal welfare requirements of each certification and how well these requirements address the 5 key areas of the animal welfare as defined by the 5-domain model. And just quickly or briefly, the 5-domain model, it was established by David Meller and others. And we as for PAWS, we are referring to this model as it's one of the most comprehensive and most structured way of looking on animal welfare, either in individuals or also in groups. And it has a strong focus on positive animal welfare and positive mental experiences. But how did we actually assess this risk assessment tool now? In order to obtain a risk assessment score for each of the certification or standards, we have adapted the welfare quality assessment protocol from actual animal-based parameters, such as the body condition score, to questions about whether such measures have been considered in the animal welfare requirements of a standard on which a certification is based. So we were asking via decision trees, for example, when you think about body condition score, is the body condition score of an animal regularly monitored, and are the workers who are checking this body conditions competent to assess it? Then the answers of these decision trees or to these questions in the decision trees, known as our individual single measures, then have gave us a score of 12 provisions that were also set. And these provisions were then aggregated inner score representing the domains, and this was done by applying the Schockert integral, which combines scores considering both individual scores but also the interaction between the scores. And finally, the domain scores were combined in an overall score of each standard reflecting the animal welfare status of the animal farmed under the specific standard. And this is a picture how we pictured the results, so to say. And we did this for each individual standard. And in the very outer circle, you can see the individual measures that we were asking for. As I said, adapted animal-based parameters from the animal welfare, from the welfare quality protocol. And then we were using decision trees, which gave us a score per provision. And the provisions are the second circle from the outside. And from the provision trees, we aggregated, as I said, bird and main, and then we further aggregated to a final score about the mental state of the animals farmed under the specific standard. So what are the key findings and the next steps? Unfortunately, only one of the standards we reviewed scored in an acceptable welfare category, whilst the others had a quite risk of poor and very poor animal welfare farmed under the specific standards. And what are the next steps? We have been contacting the certifiers and standards owners to also hold one-on-one meetings to talk to them about the results and also giving them more info what they could actually improve within the standards. And we also have published a scientific paper about this method behind. And the next steps are to reassess our results and see if standards owners actually improved with animal welfare. And we keep on reassessing them to see if there is some change over time. But for sure, there's a lot of work to be still done. And with this, I came to an end. And I want to also thank you to listening, my colleague Kaya, who did most of the work I presented, especially data analysis and the method behind. I'm just substituting her today because she's on maternity leave. And also thank you to all the colleagues that were further involved. And yeah, thanks for you to listening, and I'm happy to take questions. Daniela, any questions? While we're waiting, if anyone wants to put their hand up, I was just wondering about, is there any evidence that there's kind of a lack of awareness by consumers about the conditions of animals used for fashion, I think, compared to, say, farm animals? And so like consumers are wishing that there is a good animal welfare behind the products they are buying. But if they're really aware how bad the situation is, I don't think so. Yeah. Because this topic is rarely touched. There are certifications and some consumers are paying attention, I would say, but the actual problem behind the whole industry, I doubt that there's a lot of awareness. Any questions? Yeah, that's fine.
Thank you. Thank you for a very nice presentation. Björn Faulkner from the University of Copenhagen. I was just wondering, you may have said it, but I missed it. So how did you set the thresholds for what is being acceptable or not acceptable? So
this was actually adopted from the welfare quality protocol. So they also had this some kind of ranking, and we just adopted this.
But in the welfare quality protocol, what is acceptable or not on farm level is actually, and you can't be over a certain level, but at least 4 have to be over, 20% under, etc. I mean, it's a very complicated setup, and it's not based on the 5 domains.
Yeah, so we tried to somehow integrate it also we used the 5-to-NIM models because we also wanted to have the mental state somehow integrated, and then we somehow applied or not applied, tried to make it as it is in the welfare protocol, but I can't really say how this was done because, as I said, I'm just substituting my colleague.
Okay.
So I'm not so familiar how this actually was done, but it can be read in the paper that we also published, which is called Animal Welfare Risk Assessment in Fiber-Producing Animals, Applying the 5-Domain Model. So there is this description, but I'm really sorry. I just know that this was adapted from the welfare protocol, but I don't know how they then changed it or applied it to the 5-domain model. Sorry.
Thank you. Thanks.
Daniela? Okay, so we've got a slight change of pace now. So we've got 3 short talks, which will be 3 minutes long, and they'll run back to back. And what we'll do at the end is invite the speakers back up here to answer at least 1 or maybe 2 questions each. So first up, we have Kelly Yarnell, Window of Opportunity, Integration of Internal Chat Hatches in Equine Housing Impacts the Physiology and Behaviour of Stabled Horses. There we go. Might be that one. Yeah, that one. Oops. Yeah.
Okay, so I've been working on this being a 5-minute talk and my PB 6 minutes. So it's going to be some rapid live editing going on. So basically, we took an opportunity when we were developing our housing at Nottingham Trent University, and we found that a very minor and low cost modification benefited the well-being of our horses. I could probably sit down, actually, to be honest. That was kind of the overview of the study right there, but I just want you to have a look at these images. These are our welfare-friendly housing designs on campus. So this horse is spoilt rotten. It has its own patio, sand paddock coming out of its stable. These horses are in an American barn system, so they can see an individual opposite them. They also have a window to the outside world, and they also have what we've termed chat hatches in between the stables. So the majority of our horses are in this housing design. We do have other yards that are termed a bit more restrictive, so traditional UK design stables. So what we did was we modified those stables and we tested how those adaptations benefited the horses, if indeed they did. So the horses were in their normal social boxes. We took several different measurements. The key measurements I'm talking about today are we collected fecal samples daily from every horse to look at cortisol metabolite levels. And we also looked at 2 major behaviours. One was recumbency behaviour. So if horses are lying down, that's seen as a positive indicator of welfare. They need to lie down to gain REM sleep. They can sleep standing up, but they do need to lie down for their REM sleep. So we looked at amount of time spent in recumbency, and we also looked at amount of time spent looking over the stable door. So this is our restrictive housing here. It's not really restrictive, it's a traditional stable, but the only way the horse can see a conspecific is to look over the door. The window in the background was glazed and barred, so they couldn't stick their head out like they could in the social housing. And what we found was the horse would take a mouthful of its food, go and stick its head over the door, have a look around as it was eating, go back, get some more food, and so on and so forth. So we wanted to see if installing our chat hatches in the restrictive housing made a difference to that behaviour. So the horses were in their normal social box. They were moved to the restrictive box at the bottom for 5 days. We took measurements. We then put them back into their social box. While they were in there, we modified this restrictive housing by installing chat hatches, so windows between the stables, and then we moved them back in once the housing had been modified. So generally what we found was there was no difference in cortisol metabolites, so that regardless of housing type, that didn't make a difference. We did see a change in their recumbency behaviour, so they tended to lie down more in their normal social box and in the modified restricted housing when compared to just the restricted housing without the chat hatch. We also saw a marked change in the amount of time they spent with their head over the door. So they spent a lot of time in the restrictive housing, stood with their heads over the door, looking at the outside world. But in their social box, and once the restricted housing was modified, they spent significantly less time. So they were in their stable more, interacting with the companion or their neighbour through the chat hatch. So I think the reason we wanted to bring this and talk about it is it was a small study, but it was very applied. And the key take-home message for us is that past research has looked at kind of very extensive housing systems. They're fantastic. There's lots of very novel ways of housing horses. Not everyone can afford it. And not everyone has the land to accommodate that sort of design. And what we found was this very minor change brought about what we kind of feel as a potential benefit to horses. It's something most horse owners can do. I think if I really had to, I could do that myself and knock a hole in the wall between two stables. So we just thought it was worth mentioning that this very low cost and minor modification could be of benefit to horses as a social species. I realize in that image, this horse doesn't look too impressed that its neighbour's bothering, but he does enjoy it. They are friends. It's just, he is looking at the camera like, really not today. So yeah, that was kind of our take-home message from this work. It's a small change that can make a difference to horse well-being. So the next steps, so we do have a huge housing review. We've conducted a global meta-analysis and systematic review. I am busy working on reviewer comments. It is in the UFAW journal. So I'm just hoping to get that out soon. The reviewer comments were fantastic and very constructive. So stay tuned for that. We are helping the BHS back in the UK with their housing guidance. And we would love to do some of these things up here, looking at the impact of housing more long-term on more horses, try and come up with a common methodology for research to be able to compare our findings, which we found was a problem in carrying out this review. We also have air quality work underway because we were very mindful when we were carrying out this study that in the more open systems, and even when the chat hatches were installed, a very rudimentary look at air quality with a piece of equipment from a medical technologies facility found the air quality did improve. So we want to try and build on that and look at air quality work as well. And that is in a nutshell, the take-home message. Have I done that in how long? Oh, no medal. So thank you.
Okay, so yeah, thank you, Kelly. I should say as well that most of the short talk presenters also have posters as well. So if you want more details about any of the studies, then you can go and find their posters. So next up, it's Lauren Young talking about barbering in lab mice. Is it this one?
Yes. Hi, everyone. My name is Lauren. I'm currently the program manager at the 3Rs Collaborative, but today I'm actually talking about some work that I did in my master's at the University of Guelph with Dr. Georgia Mason, where we investigated risk factors and behavioral correlates for barbering behavior in laboratory mice. So barbering is defined as the plucking of either fur or whiskers. When it involves the form shown in the pictures here, it's one cage mate plucking from another, often called cage mate barbering or allobarbering. But another form is mice plucking fur from themselves, which we often call self-barbering. But what these different variations really show is that barbering is a heterogeneous behavior and doesn't look the same every time it occurs. But why should we care about barbering and further investigate this behavior? Well, there's a few reasons. One, for the barbers, we know that similar behaviors occur in humans that are actually pathological, as well as in animals in states of poor welfare. So barbering could be potentially indicative of poor welfare in the mice who perform it. But also for the victims, whiskers are an important sensory tool for mice. So when these are removed, they lack that. And the plucking could also actually be painful, with both of these factors also having potential impacts on research. And so overall, this work had two main aims: to replicate findings about risk factors impacting barbering, and also to test hypotheses about the origins of barbering behavior. So first, we looked at demographic factors similar to pathological plucking in humans. And then we also looked at environmental factors, potentially increasing the risk of barbering. And our second aim was to test 3 hypotheses about the origins of barbering. That barbering originates in social affiliation, it's like human hair plucking, or it represents a dominance behavior. And ultimately, both of these goals, or both of these aims, work towards the goal of helping us find cures and/or prevention strategies for this behavior. So overall, we found when looking at risk factors that whisker and fur barbering actually had different risk factors. So the risk of whisker barbering was increased by age and being female, while the risk of fur barbering was increased by being housed higher on a mouse rack, so closer to the ceiling, as well as further away from the room door, which was actually the opposite of the prediction. And then in terms of our hypotheses about behavioral origins, we found that whisker barbering was significantly more prevalent in conventionally housed compared to well-resourced housed mice, so mice with enrichments or larger cages. And we also found that agonism performed by barbers increased as mice became closer to being spotted as a barber. So overall, this work raised further questions for future research. One being, why did we see that barbering risk actually increased as we moved further away from the laboratory room door? 2, why did we see this impact of housing in our second goal, but we didn't see this in our risk factors assessment? And finally, do barbers potentially have pathological brain changes similar to humans that show this behavior? So I do have a poster. Come visit me if you have more questions. And I'd love to talk a bit more about how we did this work and what these findings might be. Thank you.
Thank you, Lauren. So next up, we have Mariana, who's talking about factors related to life expectancy and cause of death in dogs in Italy. Oh, it's not there. Do you know, does anyone know where it is? Recognize yours on that? Can anyone on that?
I don't know, maybe it's outside as a separate presentation.
Oh, okay.
Which one? That one. Good morning, everyone. Sorry, just to adjust to my short height. I'm here to present our study on the, I'm sorry, the layout went wrong somewhere from Mac to Windows. So our study was about the life expectancy and cause of death of Italian dogs. And this is the result of a collaboration of more than of 9 veterinary teaching hospitals and 2 public health institutions. And we collected data about almost 5,000 dogs that died between 2004 and 2020. Why we did that is because, as you all know, dogs exhibit an extraordinary phenotypic variability that is the result of extreme and intensive selection processes that have also led to reduction in genetic variability of breeds and also the undesired promotion of the harmful characteristics. So there are a few studies, both country-specific, like in UK and in Sweden, and also breed-specific, but there were no data for Italian dogs, so we tried to fill that gap. What we found is that longevity increased significantly in bred dogs compared to purebred dogs. Neutered dogs lived longer than intact dogs, and dogs of the smaller breeds lived longer than larger breeds. And this was basically confirming what was found in previous studies. And also, interestingly, dogs dying of euthanasia lived longer than dogs dying for natural causes or fatal accident, even though euthanasia is an artificial termination of life. We also classified cause of death by pathophysiological process and organ system. And as for the first, neoplasia was the most frequently cause of death, especially of the hematopoietic system. And for what concerns organ system, the renal urinary system was the most frequently involved. But we also saw that cause of death was significantly different according to the different breed, but also size and sex and neuter status. And that cause of death also influenced the duration of the dog's life. So this is just a taste of our results. I was intentionally mysterious, and if you want to find out the details, please come by the poster. What's the impact of studying longevity and cause of death in dogs? First of all, of course, it's dog welfare and health. And we think that the focus should shift from mere duration of life to quality of life, because we found that some breeds have a very worryingly short life, but also those diseases that are chronic and incurable have also a huge impact on welfare. The study is also relevant to owners in order to guide them when they want to purchase a purebred dog, but also when they have to make health decisions or end-of-life decisions for their pets. It's significant to breeders in order to assist breed selection and also identify priority diseases to tackle in order to improve breed welfare. It's helpful to veterinarians so that they can be aware of breed predispositions to diseases and also facilitate early diagnosis. And finally, it's also useful to humans as a species because dogs are a very good translational model, given their genetic similarity to humans, the fact that they share so many hereditary diseases with us, but they also share the same environment, exposure to pathogens, habits, and also risk factors as humans, since they live very closely to us. And so they are a very good model also for spontaneous diseases as aging. So thank you. This is what the poster looks like. You will also find a QR code with a link to the full paper that was published in the meantime. This is my face, so you can also find me around and ask me questions. Thank you.
Okay, thank you, Mariana. So if we could just have Kelly, Lauren, and Mariana back up, just for, we've only got time for one question each, really. So if you've got some good questions, there's a question over there. Do you want to? Yeah.
I have a question for the last study. I was a bit surprised what you said about the purebreds, because the three main studies done, Macmillan et al., Ting et al., and also a Danish study, show that some of the purebreds are actually live longer than the mixed breed.
Yeah.
So you must somehow mix it together, because as I understand, all the other studies, which are much larger numbers, show that some of the purebreds like Yorkshire Terriers and things like that, or Jack Russell Terriers, actually live longer than the mixed breeds.
Yes, thank you for the question. So the limit is that mixed breed dogs were considered as a unique group. And of course, this group includes dogs of very different sizes. And size is a very relevant factor that reduces longevity. So if you will be able to see that in our poster, or the longer living breeds were small size breeds like Yorkshire, Poodle. So our results were actually in line with other studies at the breed specific level. But if you consider them as a unique group, then the variability in terms of size and the fact that crossbreds have a more robust genetic background, as promoted by and demonstrated by some studies, they gain 1 year longer than purebred dogs, again, put together. So yeah, when put together, yeah. And that's okay. It's so if we put all the purebreds together, of course we have different sizes.
Yeah, but I mean, putting purebreds together, I think is a big mistake, because there's a huge variety among the purebreds. I mean, if you just add all the purebreds, that's sort of cheating, I would say.
Yes, that's why we considered both as big categorization and also at breed-specific levels. We did that both.
Mariana as well. And
there's one for Lauren here from the online. Did you consider early weaning and litter size as a risk factor for the development of self-barbering in rodents? And should this be studied further, or is it already known?
We didn't consider this mainly because we're collecting data pretty opportunistically to assess the risk factors, and so we just decided to not include breeding mice. So there weren't any like breeders involved in that data set, but there is a lot of research on that and the impacts of breeding on barbering.
This on? There we go. Yeah, you might have mentioned this and I missed it. What's the advantage of the wall in the first place? Like, what's the advantage of having a wall between two horses?
So it's just do you mean in the traditional stables?
Yeah, basically, like,
Yeah,
it's surely like tearing down the walls easier than putting a window in.
So oh, I'm sorry. There are times when you need to house horses individually. So for quarantine, isolation, injury recovery, that sort of thing. I know the Swiss National Stud don't have a chat hatch. They have an entire kind of gap from the ceiling to the floor that has bars that the horses can groom each other through, and they're using that in stallions. So there probably isn't, beyond the reasons I've given, any advantage apart from those things to having a wall. I'm not sure I could have pushed the university enough, though. To be honest, the research we carried out back in 2008 that was part of my PhD looked at very UK traditional box stables, and we found quite marked differences in the horse's physiology and behaviour and handleability, and we did bulldoze those stables, and that's why we've got a much more open system. For a long time afterwards, I thought, I hope I was right. And we have very social housing combi barns, like on the image with the big sand paddock. It's just the point of that research was not everyone can do that. So it was just something where they could maybe talk, if they're on a livery yard, say, and they paid to rent their stable. Again, I don't think the livery yard owner would be happy with them knocking an entire wall down, but a window might be a compromise. So yeah.
Okay, thanks.
That's it then for this session. So thank you so much to all the speakers. And I'm guessing lunch is out where we had the break.
Out there and the sun's out, so we can go and sit on the terrace and you can take your food there. I think the best food is probably in the other room, and that's where the better coffee is, but we've got also food in with the posters for those who are lurking there. If you're presenting in the session after lunch, if we can load your talk up, that would be great. And if you, once again, if you need more toilets, they're down on the floor that you came in. So back at 2:30. Thank you for your patience with the morning sessions.